Explicit instruction is a way to teach skills or concepts to students using direct, structured instruction. It helps make lessons clear by modeling for students how to start and how to succeed on a task and giving them lots of time to practice. Have you ever tried a new recipe only to find a step missing or unclear? Or maybe the directions had too much information for your brain to handle. You may have been able to guess what to do next, but maybe the confusion was enough to stop you from cooking the dish altogether. I know that I have experienced that multiple different times trying a new recipe. But you know, the same thing can happen to your students when they learn something new. Some students are able to go ahead and persevere and work through the problem. But for other students who learn and think differently, one unclear direction or having too many things to remember can be the deal breaker. That's why it's important for you to make sure that your lessons are crystal clear and complete. And one way to do that is to use explicit instruction. Explicit instruction is a way to deliver direct, structured instruction to students from kindergarten to high school. It helps make the lessons crystal clear and shows the students how to start and succeed on the task. You can use explicit instruction with your whole class, or you can use it to reteach or pre-teach a skill to one student or group of students. Explicit instruction is a well-researched and highly effective instructional practice. It makes higher order thinking and inquiry-based learning easier. Explicit instruction gives students who typically are left out of inquiry-based learning the information and skills they need to engage in. Explicit instruction can also teach students the processes needed for inquiry-based learning. For example, in a science class, a teacher may begin the year by really scaffolding how to run an experiment. The first time through, she may really guide the students step by step with explicit directions on how to create a hypothesis, run an experiment, and how to draw conclusions from the data you've collected. The second time in an experiment, she may provide the students some guided instructions with much more briefer instructions and making sure that each group of students is performing the experiment in the procedure that it should happen. And possibly the third time through, she pulls that scaffolding totally away and the students are on their own independently conducting that instruction. Also, there's less load on working memory for many students. Students who learn and think differently often have trouble with working memory. For example, they may struggle to make sense of a long series of direction. Explicit instruction breaks down learning into smaller parts, lightening the cognitive load. That frees up the student's working memory, which is important because learning new skills requires a lot of working memory. It also supports those students that have difficulty, where attention and helping attention to be less of a barrier to their learning. Without explicit instruction, students who struggle with attention may not be able to attend to the most crucial ideas in a lesson. With the explicit instruction, you can help cue the students to the most essential information by scaffolding the directions, breaking them down into smaller parts. It also helps, it also helps overcome language barriers. When you use consistent and clear language in each step of the instruction, our ELs aren't overwhelmed with managing new language demands. Research has shown that explicit instruction is correlated with increased achievement gains among our ELs. It also allows for various degrees of practice. Explicit instruction is also effective for students who need intensive intervention, including those with learning disabilities. Typically, these students need to practice a skill 10 to 30 times more than their peers. Explicit instruction can give them those opportunities. And also, it allows you for data collection and analysis. Each time students practice a skill, you have a chance to collect data. After the explicit instruction cycle, you can use the data to plan your next lesson, whether it's a reteach or moving on to the next skill. Vygotsky's influence has continued throughout our education since he came up with the zone approximate development. As you remember, there were 3 stages of that, of the zone. One where the learner cannot accomplish anything by themselves that is outside their zone, and they are unable to complete even with the help of an expert, and the expert being you, the teacher. If that task isn't within the learner's ZBD, the expert may look to decrease the level of difficulty and find tasks that are appropriate for that learner's skill level. Then there are the learner who can accomplish it with assistance. When a learner is close to mastering a skill set required to complete a task, but still needs the guidance of the expert, we call that being in the zone, or the zone approximate development. And that's where we try to hit with our lessons, where our students where we as teachers use various techniques to help this student better understand and learn the concepts and skills that are required to perform the task on their own. And then there's the stage where the learner can accomplish the task without assistant, actually do it independently because they have mastered the skill set to do so. And this learner does not need the expertise. When a learner has reached this stage, the expert may decrease the task difficulty level in order to find this learner's next zone and encourage further learning. The key factors from this, though, is that out of this theory, out of Vygotsky's zone, it was expanded by many other researchers into what we call scaffolding. This is where we put scaffolding into effect when a teacher is in their zone, and then we provide the assistance to help them accomplish the new task or skill. The activities, instructions, and tools and resources that we use are to aid in the learning process are known as scaffolding. And exactly, the explicit instruction model is a scaffolding model. When you look at examples of scaffolding in instruction, it could look like teachers modeling, teachers doing think aloud, using prior knowledge to link and make that connection to the new learning, using visual aids, and also using our UDL practices. And eventually scaffolding can be removed, and then students can complete the task independently. So when we talk about scaffolding, it means that we're really breaking it into chunks. We're providing tools or a structure with each of the chunks. So if you look at the explicit direction and explicit instruction model, we have the 3 stages: the I do, the we do, and the you do. And that's where we are breaking it into chunks. The teacher will model, then the teacher will do guided practice, and then we withdraw some of the scaffolding, and we have the students do independent work. Okay, just like this. So it's the I do, show the students what to do. The we do, provide students with opportunities to practice. And the you do, provide students opportunities to practice on their own and or with their peers. And I'll oftentimes take a look at your students before you totally put them on their own, a really good practice is to have some collaboration time between students and then provide them with the opportunity to do independent work. Okay, so if we take a look at math, and looking at a math lesson based on the I do, we do, and you do model with the gradual release of responsibility. And what they mean by the gradual release of responsibility, that is gradually taking away the scaffolding. I do, we do, much more scaffolding. You do is when we're gradually taking away that responsibility through that whole process. So in the past 15 to 20 years, there have been huge shifts in math instruction. And that's where our new standards came in. Previously, math really, as you know from your math methods class, math was basically procedural fluency, meaning that math was memorized and students were just learning how to perform the procedures. Now math is really focused on a balanced math instructional program. Procedural fluency is still important, but math is about understanding the processes, the conceptual understanding, and problem solving. And that means, and to reasoning out, solving problems. Now, when you think of the traditional math model of teaching math, the I do, we do, the traditional method, it might look like this. I do, the teacher models the procedure. We do, the students work similar problems with the teacher. And you do, the students work similar problems independently. And it might look like something like this. Boys and girls, today we are going to see all the ways to make number 5. So I basically think of this as a kindergarten lesson. Okay, put out 5 counters with the red side up, just like I have mine. 0 and 5 makes 5. Now it's your turn, the we do. Now we turn your first counter to the yellow side. 1 and 4 makes 5. Turn another counter to the yellow side. 2 and 3 makes 5. So this is really a guided method and would be I do, we do, and eventually students would be working to make combinations of 5 with different numbers. So what if you flip the script and made this more of a student center model? So think of it as you do, we do, and I do. So the you do would be students work together first to solve a problem. The we do, teacher and students discuss the strategy used. And then the I do, where the teacher facilitates and makes that mathematical connection. So it might look something like this, okay? Where a teacher or I would give a math problem. And so remember, this is in kindergarten. So you might have this math problem up. Stefan has 5 cookies he wants to put on 2 plates. Use your counters and paper plates to show how many he might place and show how he might place the cookies. Can you think of more than one way? So after giving the students a few minutes to work on the problem, you do, I would ask the students about the combinations that they discovered and record them on the board. So what you would have the students do, you pair the students up and experiment and explore around the different combinations that they could come up with by putting the cookies on the plate. Okay. The next thing, I would ask them questions about their process and looking at the patterns that we see, the we do. So I would be putting those up on the board, all of their answers, and talking about how they came about those different combinations. And then I might want to extend the activity by asking them, I wonder if we found all the ways of making 5, and then discuss the different ways to organize our data to help them determine if we found all the ways. So I might have this up on chartboard and the way they gave me the information, and then I would have the students looking at that information And then together we would organize it to see if we could come up with a pattern. Finally, at the end of the lesson, I would consolidate the learning, the I do, and asking the students to reflect on what they learned and stating my teaching point. There are many different ways to make numbers, and we call them combinations. Notice that with this type of lesson, the students are actively involved. They're working with a partner that's encouraging mathematical conversations. They're making discoveries on their own, and they take ownership of their learning. So thinking about your math methods classes, I think you can probably see the connection to your CGI lessons and the things that you are learning and the methods that you are learning in class. So what I'm hoping is that by looking at the explicit instruction model, that you can also look at your students, your assets, and your learning needs of your students, and come up with some very effective math lessons that will support all of your students. So thank you for listening, and